Hello and welcome to the C++11 Beginner Tutorials by Gamer2Creator. I'm Chris. Okay, we're going to cover a couple of things in this lesson, and we're going to get into arrays and dynamic arrays, because sometimes when you're writing code, you know that you need uh, an unknown quantity of particular objects. Like, let's say I know I'm going to need, I don't know, like a handful of foo objects, but I don't know how many right now, but I'm going to grab that number from a file, or I'm going to get it from the internet, or I'm going to calculate it from some numbers that could be changing. And that number will be determined at runtime. So that's an array. We've covered arrays, but we haven't covered how to create an unknown number of objects at compile time that will be created at runtime. And this also involves dynamic memory. If we're going to create an array of foo array, let's say 10, and I don't even know if that will work because we don't have the constructor needs to be called. That constructor will be called. Okay, so here we have 10 objects of foo, and obviously we can go through, we can go foo array, let's say the first object, dot, and then as you can see we actually have an object there, height and width. You can do the second one in the array at index 1. Or you could loop over them for int I equals 0, I is less than, we'll say 10. It'd be better to use a variable here, I plus I. And this should be review for you guys. And now we're looping over every foo in that array, and we're going to set height equals 10 foo array I dot and width equals, let's say, 20. And we don't need that. So here we've created an array. We know how many objects we have right now, and right now is considered compile time. I would rather use a constant foo array size equals 10, and that just makes this code, constant int. That just makes this code a little bit more manageable and elegant. And there, instead of passing around, instead of just saying 10, you can have your array size as a variable. And it has to be constant, because we know this at compile time. So we have our 10, and as you can see when I mouse over it, it still shows 10 inside the brackets. And we don't have that anymore, so we'll clean that up. And we're going to come down here, we're going to look inside this array at runtime in the debugger. And we don't need that guy. As you can see, our foo array, you can see every object in here and its index. And you can see the values. We set every single one of them to 20 and 10. Width and height. But let's try to set this to a number that we get from console. So let's do a int array size equal, we'll say 0, but I've got a new keyboard, I'm not used to it. Then we're going to say sin array size, That should be std, and we need to include the header file. Pound include iostream. Alright. Okay, so we're going to get from the console how many foos we want. As you can see, there's already a squiggly line here, so that should give you a heads up that there's something wrong. And when we try to compile this, we get several errors. And it said expected a constant expression right here. And I couldn't allocate an array of constant size 0. Even if we set this to, let's say, 10 at first, it still won't work. So why is this? Well, because you have to know the difference between compile time and runtime. Obviously, if we're going to get the number of foo objects we want from the console, that is runtime, and not now when we're writing the code. But we can still do this using dynamic memory, which means we have to use pointers. Okay, so we're going to say int pointer to a foo array equals new foo array size. Alright. Now we're going to have to change our variable down here. So that this variable matches this. So we have our foo pointer to an array. Now think of this just the same as creating one foo, where we use new foo, but now we're using the brackets to say, okay, not just one, we want this many. I want 5 or 6 foos, and I want a pointer to those. And then this will store that pointer for us. Now you have to think new as an operator that's either just new or new bracket, because you also have delete and delete. Okay, so you have to match these. If you're calling new and using the bracket down here like this, then you're going to have to call delete on that pointer and not just regular delete. Okay, so let's make sure that this actually works. Now remember, we're going to ask the console for the number. Now here's my little console window, and I've got the little caret flashing, and I can type in, let's say, I want 5. I hit enter. Alright, so behind this window, the program has hit the debugger breakpoint. You can see that array size actually has 5 in it now. Instead of 10, which was the default here, it's got 5, which is what I inputted. So far, so good. Looks like we've created an array of foo, and we have our pointer to the foo array. These values have not been initialized. These values have not been initialized yet because we haven't run this code. So they're just holding junk currently. I'm going to let this loop run. Well, I'm going to show you once and then I'll let it run. And as you can see, this little, the bracket operator here says, alright, this is the beginning of the array. Get me the nth number in that array, or the nth index. And I've used the variable I. So on the first loop, it'll be 0, I equals 0, so that's the first one. Followed by the next one, which is index 1, and we're changing those values of the object at index 1. We're changing its height and width. Now I'm going to let this run. We get down to here, we see our proof pointer array. Now because we just used a naked pointer, we don't get to see all the values because it actually doesn't know how big this array is. We only see the first one. But this is the basics to dynamic memory. Now we've done one mistake here. We haven't matched our new with the delete. And as I mentioned earlier, if you use the brackets new to create an array, you have to use the delete operator with the array symbol on the pointer to delete it properly. This is incorrect. This is correct because we use new with the brackets. And then usually you'll say pfoo array equals 0 or null pointer is the C++11 way. So I could create as many foos as I want to, and I can, let's say I want 1,000. And I didn't put any breakpoints here. Let's go down here and put a breakpoint. 1, 2, 3, 10,000. Why not? So you can see that there's junk in here still. But my array size is 10,000. And I use that to loop over that pointer to index the nth index and change those values. So I've actually got 10,000 foos now in this array. But here's a interesting thing, and it's something to think about as we move into the next lesson, and that's that what if you wanted to pass this array into a function? Well, you've already got a pointer to it, so you would be able to, let's say, let's just say sum widths foo pointer array and int size. So what we want to do, and I just made this up as an example, is we're going to pass our array of foo objects by pointer to this function, and we're going to add up all their widths. But if we only pass in a pointer, then how would we know how many times to loop over this array? We wouldn't. There's no way to tell until you pass in the array size as well. And that's why I stored this in a variable all its own. So here we can call sum widths pointer to the foo array and the array size. Okay, so far so good, I think. And we'll do a foo int I equals 0, I is less than array size. Okay, so as you see, we had to pass two separate pieces of data to make this work. And we need to return workings. Because all we have is a pointer. Pointer to an array, but it's really just a pointer to a memory address with a certain type, and that's a foo. So we had to tell it, okay, this is an array, and we have this many at that address, starting at that address. So as you can see, we have to pass around multiple pieces of data that aren't attached in any way, except logically to us. And that's where vector comes in with dynamic arrays, because the vector is a class that will create your array dynamically, manage it, grow it, shrink it, do whatever you need, and store the size along with it so it's compact within an object. Just like our data is within this foo, vector wraps dynamic arrays and makes sure to handle the new and the delete and to tell you how many objects are in there, how many objects could it hold, all this information all wrapped up together and can be passed as one variable. But let's make sure this works first. Okay, hope I didn't make any mistakes. I'm going to say 10. Now the reason I chose 10 is because our widths are 20. And if we have 10 of them, we should expect some widths to return 200, and I did make a mistake. Forgot to store that value. I'm going to use 10. And result is 200. So obviously it worked. It looped over every object in our array that's pointed to by a pointer. And it knows how many objects because we passed the size. It added them up and returned the result. And that's, you're getting into really seeing the whole picture of C++, and you're getting into the complexity of C++ and why classes that are in the STL can make your life a lot easier. They handle a lot of this for you. Alright, so let's do this again. We're going to do this again with a vector. And I'm going to have to include std. And this is a template class, but we've already talked about that, at least in the sense of vectors. And we're going to have our, let's call it foo vector. And let's say we want to have 5 of these. Well, we're going to use array size because array size was come from sin, or the console. Set a breakpoint there. I'm going to type 5. Now we're way down here. Now if I look at the foo vector, you can see some of its internals, and that it actually has 5 objects. And it has a capacity, an internal capacity of 5. And it has our objects there in the array. And we do not have to call delete on this vector because it will handle it for you. The destructor of this object, when it falls out of scope, will run and free up the dynamic memory. It did this internally. It'll free that up for you. So I highly, highly, highly recommend to use a standard template library class whenever you can. You'll still get all the benefits of C++ because internally it's still doing this pointer stuff. It's just correctly managing it for you. And you can loop over it, and you'll see that for int I equals 0, the size foo, I is less than foo dot size. You can always grab the size through that field. This method returns the size, which is stored internally for you. And this is how you would loop over it. Foo vector I dot L M I, we'll just say times equals 2. We'll multiply it by 2. As you can see, this is much cleaner, at least so far. It looks a little bit cleaner anyway. And you're not having to handle this stuff on your own. But now we could actually just pass and we're going to pass it by reference, so we don't have to copy the entire vector and all of its internals. We're going to say foo_vec. So I hope you can see how this is starting to get cleaned up a little bit. I don't know why that's... Oh, right. Okay, so we change this. That version of it doesn't exist anymore. Now we can just pass the vector by reference, and it will be able to grab the size from within this vector object. This is where you can start to see how classes and object-oriented programming, you can wrap stuff and pass it all together to very simplify your task. And also to store related data together logically and easily. Okay, I think that'll just about wrap up our lesson on dynamic arrays. I hope to see you in the next lesson, as I plan on moving into some more C++11 and having a little bit more fun and maybe even some homework. So I'll see you in the next one.